Okay, so this is going to be our first cumulative review of free response questions. I know it says BC at the top. So AB, you're going to ignore the last question because it's going to be dealing with Taylor series. So just ignore it whenever you're doing your notes and the video. Okay? So it says water is pumped into an underground tank at a constant rate of 8 gallons per minute. Water leaks out of the tank at a rate of square root of t plus 1 gallons per minute from 0 to 120. It says at t is equal to 0, the tank contains 30 gallons of water. How many gallons leak out of the how many gallons of water leak out of the tank from 0 to 3? Okay, so for part A, it's leaking out at a rate of square root of t plus 1. So we're going to integrate to find the amount. Okay, so we'll integrate this. We're going to do a u sub. We're going to add 1 to the exponent divided by the new exponent. Your u is t plus 1. Your du is just going to be dt. Okay, and we're going to go from 0 to 3. Now we're going to plug in our top limit. And we're going to plug in our bottom limit. Okay, so doing this without a calculator, square root of 4 is 2, 2 to the third power is 8. So this is 16 thirds minus 2 thirds, which is equal to 14 thirds gallons. Okay, so that's part A. Part B, it says how many gallons of water in the tank at t is equal to 3 minutes. Okay, so it's important that you know that the volume. So this is kind of like what we call an accumulation problem. You got something in, something going out, and you have some initially in the tank. So water is being pumped into the underground tank at a constant rate of 8 gallons per minute. So however many gallons after however many minutes, so this gives you the total amount that enters the tank. Okay, if you wanted to integrate that, you could integrate that. Plus, we're going to integrate from 0 to 3 of square root of, sorry, that's minus because it's leaving the tank. Okay, and then you initially have 30 gallons of water in the tank. Now, we already have this value from the previous part of the problem. 8 times 3 is 24 minus 14 thirds plus 30. Okay, getting a common denominator and doing all that fancy junk, you should get 148 over 3 gallons. Okay, so enters, exits, initial amount. Part C. It says write an expression A of t for the total number of gallons of water in the tank at any time t. It's pretty much the same thing as what we just did. It's going to be 8t minus whatever integrates from 0 to t. And we have 30 in there initially. Okay, so enters at any time, exits at any time, and then this is going to be your initial amount. Part D says for what time is the amount of the water in the tank a maximum? Okay, so remember, maxes occur where the derivative goes from positive to negative. So we're going to take the derivative of this. The derivative of 8t is 8. The derivative of an integral is just the function itself. The derivative of 30 is equal to 0. Okay, so we're going to set this equal to 0. Square both sides. So t comes out to be 63. And to prove that it's a max, we're going to plug into our derivative. Okay, and we're going from 0 to 120 is the max time. Okay, so if I plug in, like, say, a 1 into my derivative. So 1 plus 1 is 2. Square root of 2 is like 1.41. So 8 minus that is a positive number. And if I plug in something like a square root of 81 or something like that, it's going to be a negative number. So this is a max. And that's all there is to this problem. And we're going to practice a lot of these because it's a good candidate for being on free response every single year. Okay. Next portion, it says show that dy dx is equal to that expression right there. So we're going to have implicit. So we're going to write the first term, derivative of the second term, plus write the second term, derivative of the first term, minus, we're going to write the first term, derivative of the second term for this portion, plus write the second term, derivative of the first term. Now remember, anytime we're taking derivatives y, we need to make sure we put dy dx. And the derivative of 6 is 0. Okay, so we're going to collect all our dy dx terms on one side. And we're going to end up factoring the dy dx out like we have before. Y'all should be able to do this portion without any sort of difficulties. Okay, and then we're going to divide. So dy dx is equal to 3x squared y minus y squared all over 2xy minus x cubed. Okay, and that's part A. Part B, it says find all the points on the curve whose x-coordinate is 1, and then write an equation of a tangent line for that. Okay, so if your x-coordinate is 1, we're going to go back to the original to find our y-coordinate. Okay, so we get that expression plugging it into the original. So y squared minus y minus 6 is equal to 0. This factors to y minus 3 and y plus 2. So our y coordinates are 3 and negative 2. Okay, now it says you want to find the equation of the tangent line for each of those. So we're going to plug into our derivative. So our derivative's right here. We just found that in the previous step. M of 1 over 3, plugging in, you get 3 times 1 squared times 3 minus 3 squared, all over 2 times 1 times 3 minus 1 cubed. That should come out to be 0. And your M at the point 1, negative 2 is 3 times 1 squared times a negative 2 minus negative 2 squared. 2 times 1 times negative 2 minus 1 cubed. And you should get 2 for that. Okay, so our equations of our tangent line, so it's y minus 3 is equal to 0 times x minus 1. So it's y is equal to 3. And then our tangent line for this one is y minus a negative 2, so y plus 2 is equal to 2 times x minus 1. And I know I'm going through this quickly. I'm just trying not to make the videos last that long. Okay, part C, it says find the x-coordinate of each point on the curve where the tangent line is vertical. So the tangent line is vertical where the derivative, the bottom of the derivative is equal to 0. Okay, so we're going to set 2xy minus x cubed is equal to 0. And I'm going to solve for something. Well, both of these terms have an x in common, so I'm going to factor on x. Oop. And so you get x is equal to 0 and x squared is equal to 2y. Now, what we're going to do is we're going to take that and we're going to plug in and we're going to solve for y in this one. A little tricky. We're going to solve for y. and we're going to plug it back into the original because you want to know what are the x coordinates when the tangent line is vertical. Okay, so you're going to take x times, you're going to plug in for y squared, so it's 1/2 x squared squared minus x cubed, and your y is going to be 1/2 x squared is equal to 6. So this becomes 1/4, sorry, 1/4, you gotta square everything, 1/4 x to the 5th minus 1/2 x to the 5th is equal to 6. And you're gonna combine your like terms. So x to the 5th is equal to a negative 12. So x is equal to the 5th root. This should be a negative 1/4, sorry. I'm a little distracted by the four-wheelers going on, if you can't tell. Okay, and that's what your answer comes out to be. So that's the x coordinate where the tangent line is vertical. Okay, next question. It says the function f is differentiable for all real numbers. The 0.314, 1/4 is on the graph of f of x, and the slope is given by dy dx is equal to that. So it says you want to find the second derivative. So the second derivative of this function, so we're going to write the first, derivative of the second, plus we're going to write the second term, derivative of the first. Okay, now the easiest way to do this is to dy dx is right here, and you're going to plug in your 0.314 to it. So your y is 1/4 squared, 6 minus 2 times 3. 6 minus 6 is 0, so that your slope comes out to be 0. So this whole term is going to go to 0. So you're going to plug in your y values, 1/4 squared times negative 2, and it should come out to be negative 1/8. Okay, 1/4 squared is 1/16, negative 2 over 16 is negative 1/8. Part B, it says you want to solve the differential equation using the initial conditions. Okay, so our first step is going to be separate your variables. So we're going to separate our variables. We're going to get all our y terms on one side and all our x terms on the other side. We're going to integrate. The integral of this goes to negative 1 over y. The integral of 6 is 6x. The integral of 2x is x squared. And you put plus c. Now our initial condition is negative 1 over 1/4 over here. Your x value is 3. Okay, so 6 times 3 is 18. 18 minus 9 is 9. Okay, so negative 4 is equal to 9 plus c. So your c comes out to be a negative 13. Okay, now once we find our c, we take it and we plug it back in right there. So this becomes negative 1 over y is equal to 6x minus x squared minus 13. Now when we go to solve this, we're going to divide everything through by negative 1 first. So we're going to change everything's signs. And I'm just going to write it in that order. And then to solve for y when it's on the bottom, we're just going to reciprocate everything. So y is equal to 1 over x squared minus 6x plus 13. And you are done. Okay. Last example problem for AB. And then BC, you got a Taylor series after this one. Okay, you're given a function, you're given the derivative graph. Okay, so on a derivative graph, remember that your critical points occur where it crosses the x-axis, okay? And your inflection points occur at maxes and mins on the derivative graph. So as soon as you see a derivative graph, you should start, labeling stuff like we did in class. Okay, part A, it says, on what intervals is f increasing? F is increasing where f prime of x is greater than 0. Okay, you have to write that. Okay, so where does it have positive y values? It's positive y values from -3 to -2. That's it. Nothing else to it. Part B, find the x-coordinate of each point of inflection. Okay, so points of inflection occur inflection points where f prime of x is equal to 0 and change sign. Okay, so this occurs where f prime of x has a max or a min. Okay, so from our graph we can tell that we have maxes and mins, hills and valleys at x is equal to 0 and x is equal to 2. Okay, there's nothing more to it. Portion C, it says find the equation of the tangent line for the graph of f. So f prime of 0, we read the y value from this graph because that's the derivative. So the y value at 0 is a -2. So our equation of a tangent line is y minus 3 is equal to a -2 times x minus 0. Nothing more to it. In D, it says find f of -3 and f of 4. Okay? And show the work that leads to your answer. So you're given the derivative graph up here. And we want to find the area because we're going back to the original. So what we're going to do is we're going to do a function defined by an integral. So the integral from -3 to 0 of f prime of x dx is equal to f of 0 minus f of -3. Okay, so that's what we're looking for right there, using our first FTC. F of 0 is equal to 3, and what we're going to do is we're going to use our graph to find our area. Okay, so we've got triangles here, and they're equal, so they're going to go to 0. And all I did was draw a little box, and I did a triangle right here. Area of a triangle is 1/2 the base times the height. So this area comes out to be -3/2. And f of 0 is 3. So when I solve for f of -3, it should be 3 plus 3/2, which is equal to 9/2. Okay, now I'm looking for f of 4. So f of 4 minus f of 0. Okay, so f of 4 minus f of 0. So we're going to find the area from 0 to 4. Now, this is a rectangle right here. And I'm going to have to subtract out, so it's a rectangle right there. I'm going to have to subtract out that semicircle. So this area is 4 by 2. Okay, so it's 8 minus pi over 2. Your radius is going to be 2. So 8 minus 2 pi. Okay, is going to be the area under the curve for this region right here. Okay, so, and since it's below the x-axis, it's a negative 8 minus 2 pi is equal to f of 4 and f of 0. F of 0 is 3. And solving for f of 4 would come out to be 2 pi minus 5. And that's it. Okay, BC, quick little Taylor series one. Okay, so we're given a table. It says write the second degree Taylor polynomial for x is equal to 0 and use it to approximate f of 0.2. Okay, so we're going about 0, so we're going to, we'll say it's t2 of x is equal to f of 0 is 4 plus 5x minus 1 over 2 factorial x squared. Okay, so which is 4 plus 5x minus 1/2 x squared. Now we're going to use this Taylor polynomial to approximate the value of 0.2, which is 1/5. I think it's just easier to write as 1/5. Okay, 5 times 1/5 is 1. This comes out to be 1/50th. So it's going to actually come out to be 4.98. Okay, 1 over 58 is 0.02. So 5 minus 0.02 is 4.98. Okay, it says let g be the function such that g of x is equal to f of x to the third. Okay, so what we're going to do is we're going to plug in x to the third into our function, okay, that we just found. So g of x is equal to 4 plus 5x cubed minus 1/2 times x cubed squared, like that. And I read this wrong the first time I did this, so don't do the same thing I did. It says, write the fifth degree Taylor polynomial for g prime of x. Okay, so I didn't see the prime. Okay, so the derivative of this is going to be 15x squared minus 3x to the fifth. Okay, and it's fifth degree because it's x to the fifth. Now, as you'll see in your notes, if you have any other powers out here, you're just going to cross them out and you're going to ignore them, okay? If it says it wants the fifth degree, you just fifth degree and lower. Okay, part C. It says write the third degree Taylor polynomial for f about x is equal to 1. Okay, so about x is equal to 1. So t3 of x is going to be equal to 8 plus, so we're reading from our chart, 8 plus 3 times x minus 1 plus, minus 2 over 2 factorial times x minus 1 squared. Wait, 8 plus 3 times, okay, and then plus 3/2 over 3 factorial times x minus 1 cubed. Okay, and you can leave it like that if you want to, or you can simplify it. 2 factorial is 2. Three factorial is 6. 3/2 divided by 6 is 3/12. So it simplifies to 1/4. Okay, so that's it. If we're looking at Taylor series on this AP exam for this year, I believe it's either going to be a table or it's going to be a graph, possibly for the 2020 test. So these are good questions to do, just to make sure you know how to do Taylor series. You can't cheat on anything, so, you know, it's a table. So if you have any questions, feel free to reach out. Hopefully you have a good evening. Thanks. Bye.